Okay, Pythagorean identities. Now, these identities are based around our Pythagoras theorem. So, c squared is equal to a squared plus b squared. Now, we're going to start off by actually proving one of these identities. I'm not going to prove all three because all three are done in pretty much the exact same way. But we're going to prove the first one and the main one, and then I'm just going to show you what the other ones are. Okay, so let's start off by having all the points that satisfy a circle with radius r. So that is, I'm going to write the equation of a circle with radius r. X squared plus y squared is equal to r squared. What we're going to do with this circle is we're going to divide everything by r squared. So divide by r squared, divide by r squared, divide by r squared, just like that. Okay? Now, when we do that, well, we can see on the right-hand side, r squared divided by r squared is just equal to 1. Okay? Now, using our definitions from the other lesson, we know or remember that x is equal to... how am I going to do this? X... Oh! Our definitions are cos of theta is equal to x over r, and sine of theta is equal to y over r. Now, using those definitions, what I'm going to do is I'm going to rewrite x squared over r squared as x over r all squared, and I'm going to rewrite y squared over r squared as y over r all squared. Now, using these definitions here, I can substitute them into this equation, okay? So, x over r becomes cos theta, so we get cos theta all squared plus sine theta all squared, and that is equal to 1. So this here is an example of a Pythagorean identity. Something squared plus something squared is equal to something else squared. In this case, it's just 1. But this Pythagorean identity is really useful, okay? So cos squared plus sine squared theta is equal to 1 is a very useful thing to have. Because basically, whenever you come across a cos squared theta plus sine squared theta, you can change that into a 1. So if your question is something like 5 lots of cos squared theta plus sine squared theta equals 5, okay, well, I know cos squared plus theta is actually, plus sine squared theta is actually equal to 1. So it's the same as saying 5 lots of 1 is equal to 5, okay, and 5 is equal to 5, which is true. So just having that cool little identity will help us actually solve a few problems later on, okay? So the identities, and let's write these out. So I'll write the rest out. We won't prove these because, as I said, it's done the same way, except you do it by dividing by cos squared or dividing by sine squared. So the three identities, I can't actually spell identities, it turns out. Identities are 1, cos squared plus sine squared theta is equal to 1. The second one is if we were to divide this whole thing by cos squared theta. So I divided this by cos squared theta, I divided this by cos squared theta, and I divided by this by cos squared theta. Actually, you know what? We'll even do this on the other side. So here's my identity, and I divided everything by cos squared theta. Okay, well, we know cos squared theta divided by cos squared theta is just 1. So that part's easy. Sine squared theta divided by cos squared theta. Well, if we remember our definition from the previous video, sine divided by cosine, well, that's just equal to tan. So that is tan squared theta. And 1 divided by cos squared theta, well, that's just equal to sec squared theta. So our second identity is instead, or is in fact, 1 plus tan squared theta is equal to sec squared theta. Now, the third identity we have is, instead of if we're dividing everything by cos squared theta, we divide it by sine squared theta. Okay, so we have a plus 1 here because sine theta divided by sine squared theta divided by sine squared theta is 1. Cos squared theta divided by sine squared theta. Well, using, again, that ratio identity from the previous video, would in fact be cot squared theta. Okay, so cot squared theta plus 1 is equal to 1 over sine, which is cosec squared theta. Okay, and these are our three identities. Okay, so these ones here. And so you can use them interchangeably. So if you have a cosec squared theta in your question, you can replace that with cot squared theta plus 1, and it might come in handy. And we will see a few of these in a later video where we actually go through and prove some identities, okay? But in the meantime, these are the identities that we need to remember, and these ones are called the Pythagorean identities, okay? So I'll see you guys in the next one.